Hello, everyone, and welcome to the latest in our series of Ask the Expert videos. My name is David Pike, the Connector Geek, and I'm here today to talk about board-to-board connectors. Board-to-board connectors are a vital part of modern electronic design, whether you're using hard connectors that join two boards together or more traditional discrete wire situations. But in today's designs, where we need compact shapes and complex shapes sometimes, traditional board-to-board connections aren't necessarily the right solution for all. So we're here today to talk about a different way of going about this. I'm joined today by Sobin Hiroka and David Fire of Molex, and we're going to talk about our alternative to traditional board-to-board connection technologies in the shape of flat, flexible cables. Gents, welcome. Thanks for joining us.
Good to see you, David.
Hey, gentlemen.
Great to see you both. And so I'm going to launch in with the first question. I mentioned flat flexible cables in my introduction. Can you give us an idea of what flat flexible cables are and how they differ from normal technologies?
So, David, FFCs are thin cables that are flat and that are composed of multiple flat conductors and laminated between thin layers of insulated material, primarily polyester. Discrete wire, on the other hand, are individual round wires, each having its own insulation material, making them bulky and less flexible. So that is the difference between those two.
Okay, and so you mentioned specifically flexible. These are devices that we can employ and install in different ways to traditional cables.
That is correct.
Okay. Now, can you give me an idea of some of those potential use cases? How would we go about using flat flexible cables?
The primary use of these is to connect 2 points, either a PC board to PC board or a PC board and a display unit. That's the main functionality of this type of product. Our product comes in a variety of pitch sizes. The smallest that we have is a 0.25, all the way up to 1.25 as a standard. So they come in a wide variety of flexibilities, a wide variety of speed capabilities as well. So the offering is quite large when it comes to this type of product.
So from a connector standpoint, and it's probably a good time to bring up the slide on the FPC, FFC connector types that we offer. So if you look here in the middle is the ZIF type, which is zero insertion force, and it's the most popular type. There's a lot of variations, options, pin counts, flip type or slider type that we offer. Whether front flip, back flip, vertical flip, right angle or vertical slider. And there's an actuator on the ZIF type that you open and close to lock in the cable. On the left side, you've got what we call a non-ZIF or non-zero insertion force. It's a simpler type of connector system. There is no actuator or latch that's on here. All you do is just insert the cable. You'll feel some resistance as you insert that cable, but it's a simpler process. And then on the right side, you've got a positive lock type. We've got a family that we refer to as one touch, and you just insert the cable just like a non-ZIF or lift style. You'll feel some resistance, and then when it's fully locked in, you'll hear a click. And then you've got also what we call flexi latch type, which again you insert the cable, and you'll feel some resistance. You'll hear a little click, and then again to release or unlock the cable, you have to depress the latch. And so this, the type of use case will then determine, which of these types of connectors you use. In most cases, the ZIF or a non-ZIF type will do. Those are good options for just general use, whether it's maybe a display or a camera. But if you've got a a connection that you cannot that cannot fail, say like a blood infusion pump, then a positive lock type connector is what you want to use in that case. Um, so depending on the use case and the criticality of that connection is going to determine the connector that you use.
And so when we're going for this type of solution, what are the advantages that FFCs and the connectors that go with them? What are the advantages that designers are gaining from using them?
When it comes to the FFC, there's basically three major elements: the flexibility of the cable, the space efficiency of that, and also the ease of installation. If we look at the flexibility, engineers are looking for a solution that is easy to handle, that it's easy to route within an application. So that's where the flexibility of the FFC is important. When we talk about space efficiency, this cable, as I mentioned earlier, is comprised of flat conductors with thin polyester shielding, or a thin layer of polyester. That makes this cable very low profile. Again, that's a key thing that designers are looking for. There's more and more components, content in applications, so space is key. And finally, the ease of installation. With our Easy On connectors, we provide a robust, very simple, effortless type of connection between the cable and the connector, and it also saves that time.
Yeah, so maybe to add to that, this type of connector system, it allows modularity. It's easy to swap out a module, again, whether it's a display or a camera or some sort of sensor. All you need to do is flip open the latch in the case of a ZIF connector, and you're easily able to swap out that module. Or from a repair standpoint, you got a broken camera. Again, very easy to swap out. And then from a commercial aspect, these connectors, FFC, FPC connectors, and PrimoFlex cables, they strike a nice balance between the feature set and cost. They're very cost effective. Typically these are off the shelf, readily available at like RS Components. And then, to David's point, it allows great design flexibility due to its small size, low profile, lightweight, wide pin count range, and a host of other features and benefits that this brings to design engineers.
So the design engineers with these solutions have got lots of advantages, but when it comes to specifying the products themselves, here's an interesting question: which comes first, the FFC or the connector?
Yeah, so I think in this case it's probably a little more clear. The design engineer, he needs to lay out that board, the main board, the logic board, and so whether it's the ICs or caps and resistors, the connectors also need to be laid down and make sure that there's space for all the various components that go on the PCB. So once the connector is decided, then the cable would then come next.
Okay. And what are the trends that are currently driving the demand and the advances in the world of FFCs?
In that sense, we're looking at thinner, flexible, and faster. Thinner cables, we talked about the wide number of components, greater amount of components within an application. So we need these cables to be thinner. Real estate continues to drive engineers to design things that are thinner, less bulky. When it comes to flexibility, we are seeing our cables used in automation, robotics, and we've designed cables that are able to meet that demand. We have cables that can support 5 to 10 million flex cycles. So again, flexibility is key. And finally, faster data signal transmission, faster cables that are able to withstand faster transmission. And for that reason, we've come up with our LVDS, which is a controlled impedance solution cable. And again, this is ideal for high-speed data, and it supports 2 to 10 gigabytes per second. So again, thinner, flexible, and faster is what the industry is calling for.
So David, yeah, maybe it's a good time to bring up the trends slide, at least from a connector standpoint. So some of the major trends that we've seen that have driven a lot of the innovations within the connectors, and then also the cables as well, is the touch interface. And we can thank Apple for that, with the iPod Touch, the iPhone, where they brought this very intuitive, user-friendly, sleek, high-tech looking interface. Also miniaturization, devices continue to get thinner and sleeker, and that'll be a continuing trend. The consumerization of industries, that's related to the touch interface and the miniaturization that I talked about earlier. Again, Apple with their wonderful consumer devices, this has migrated over into other industries and devices, whether it's a medical, CGM or diabetes, device or a industrial reader. They all, the users expect that user-friendly, sleek-looking type of device. So from a connector standpoint, then, this has driven, higher density, which means more pins within, within a given footprint. The touch interface requires an FFC or FPC cable and connector. Designer friendly. What I mean by that is the connectors themselves can accept like a dual contact FFC connector, for example, can accept that cable either top side or bottom side. Many of our families also offer very wide pin count range. So if a design engineer chooses a particular pin count at the beginning of the design, he can easily swap out to another pin count. In one of our families, we have it's called FD19. We offer anywhere from 40 up to 80 pins available in single pin increments. So that gives, again, a lot of flexibility. And so, we refer to that as a designer friendly. And then, of course, from a reliability standpoint, we expect our devices as well as the components inside to be reliable with the connectors and cables. We do that with either an ear or a notch that's in the cable, and then there's a corresponding feature within the connector itself to accept that the notch or ear, which gives then better retention force within the connector. So these are some of the trends that are driving the greater use of connectors and cables. And my friend Mr. Faya, he has this funny notion that that the world is flat, and I guess in the case of connectors and cables, that is the case. So touche, Mr. Faya.
There you go, Selwyn.
So we've looked at the different trends that are driving the demand for FFCs, but what are some of the innovations that Molex are going to be developing? What new things will we see in this FFC world in the future?
We're always trying to get caught up to the connector world to see what connectors are out there. And one of the initiatives that we have for 2024 is to make sure that the temp rating of our cable solutions also offer a 150C temperature rated product. Currently, 95% of our FFCs are rated at 105, but we are seeing a greater demand and interest, especially in the automotive space, for cables that are rated 150. And that's our approach, is for next year to try and release a polyester version of the 150 temp braiding cable.
So from a connector standpoint, some of the innovations that we can expect is, I talked earlier about our positive lock one-touch system. We're looking at, say, smaller size version of that, perhaps lower height, smaller footprint. Also, just in general, there is the drive for smaller and thinner. So that'll be a continuing trend or innovation. Also, hybrid connectors, where we integrate both power pins as well as signal pins within the FFC connector. This is pretty common within the board-to-board space, but this hasn't been seen much in the FPC FFC connectors. And then also automation friendly or robotic insertion of the cable within the connector. Putting in features within the connector to allow that. So those are some of the innovations that I think we can expect, and we probably should have another coffee chat about this, David, in the future.
Yes.
So we've talked about the trends, we've talked about some of the innovations that people can expect to see in this world in the near future. But what do Molex offer for designers right now?
On the FFC side, we have a wide range of standard products. Our PrimoFlex FFC product line consists of 16,000 standard part numbers. So again, that's what engineers are wanting to go to, that off-the-shelf type of product. The second thing is ease of customization when it comes to our cables. We have a wide range of custom capabilities that can be added to our cables. And the great thing about that is we offer that opportunity with a low program requirement of 3,000 piece minimum order quantity and a requirement of 10,000 estimated annual usage. Those are the min requirements that we need to support any custom opportunities that come our way. Third, integration of hybrid solutions, meaning we've talked about the Molex and the FFC cable as a full solution. We are also going after non-Molex connector solutions, meaning we are able to provide a hybrid where on one side you may have a Molex connector, and on the other side you may have a non-Molex connector. Our cables can be designed to fit both. And finally, we want to be that one-stop solution where customers come to us for that full interconnect cable and connector approach.
And then from a connector standpoint, we have what we call our 4 core products when it comes to FFCs. We've got a lot of different families to offer, but sometimes having too many options can also be challenging. So we've got these 4 core products, which we'll share with the audience later. But these families should cover 70 to 80% of what designers may need for an FPC FFC connector. And then beyond this, we've got some of that specialty connectors, as I mentioned earlier, like a flexi latch or that one-touch positive lock type. Also LVDS specific connectors as well that will mate with the PrimoFlex LVDS cables. And again, just to reiterate what my friend Mr. Faya mentioned, we're a one-stop shop, and I think that's a differentiator versus other suppliers out there. You're going to get a cable that's going to mate perfectly with the connectors that we offer.
I think that's a perfect point to end the conversation. This is a technology that if you've got a smartphone, it's something that you are using whether you realize it or not. But as we've talked about today, one of the interesting things is the way that some of this technology that you find in a smartphone has become common in industry. We've done a couple of these interviews in the past with other people from Molex. So we talked with Dean Donnelly about the idea of PLCs and industrial controls and the fact that they are employing the same touchscreen technology that our smartphones have been using. So obviously there's going to be an application for FFCs in that world. We had another conversation with Ryan Price where we talked about the future of car design and the fact that smartphone technology is already part of your car. And as we go forward into new car technologies, more of this will be available. So obviously FFCs and the connectors that connect them to the boards are increasingly important in our world. And I think it's great that we were able to take a look at the Molex offering. If you need to find out more information about the Primo Flex product, the Easy On range from Molex, there is a ton of information on RS Components. RS has a lot of these standard components available from stock so that you can get designing with this technology very quickly and realize some of the advantages that you're going to gain over traditional board-to-board technologies. And obviously we'll put more information on Design Spark. We'll put a link into those two conversations that I mentioned with the other Molex people that have a relevance for this kind of technology. So you can start to see how important this technology is going to be in lots of different industry areas. I think the last thing for me to do is say, Sobin, David, thank you so much for spending your time with me today.
Thank you, David. Appreciate it.
Yeah, thank you. And don't forget, guys, the world is flat. Thanks again.
Thanks for watching, and we'll see you again soon.